This is an example of a change of variables for a double integral. So you're given some region R that's specified in terms of x and y, and the transformation is also given. So the first thing we do is to kind of convert this this region in the xy plane to the UV plane. So in the xy plane, we will do a sketch. So x between 0 and 2, and y is between negative x over 2 to 1, y equals 1 minus x. 1 minus x will look something like this. So this is 0, 1. 0, 0. So the region enclosed is this triangle. And because it's a linear transformation, then we know that it will kind of take a triangle to a triangle. It will be slightly different shape, but it will still look like a triangle in the UV plane, which means we only need to decide where the points, where the three kind of vertices go in the UV plane. So in order to do that, we need to solve for u and v in terms of x and y. So u will be x over 2, v will be y plus u, which is y plus x over 2. Okay, and then we can do a table of how we map points in the xy plane to the UV plane. So in the xy plane, we have 3 points that we want to consider. 0, 1, 2, minus 1. So, and then based on this system of equations, we can know where they go to. So if x, y are 0, then u and v will be also 0. X, y are 0, 1, u, v will be 0, 0, 1. And then x, y is 2, minus 1. UV will be 1. So this is negative 1 plus 1, which is 0. So then we plot these 3 points in the UV plane. So 0, 0, 0, 1, and 1, 0. So we can see this. This is also a triangle, and that's our transformation T. So once we decide what the region is, we need to kind of find the limits of integration. So we need to describe this region in terms of u and v. So certainly this will be kind of v bottom, and this will be v top, and this line is uv equals 1, which means v will be equal to 1 minus u. Okay, and then to set up the integral, we know that there are 2 parts, right? One is we will replace the x and y based on this 2 equations. So x now becomes 2u. So 2u square root of x plus 2y. So that's easy substitution, and the other parts will be the absolute value of the Jacobian. So this part, it's never gonna be negative. And how do we compute the Jacobian? It's gonna be the old variables over the new ones. Old variable over the new ones. And then, so we look at these two equations. So x over u is 2. X over v is, there's no v, so 0. Y over u is negative 1. Y over v is 1. So we end up getting, so we multiply the diagonals and subtract. So 2 minus 0, which is 2. And, you know, it's already positive, so no need to take the absolute value. So this part will be 2. And then it's over the new region that's described by something about u and v. So let's try the order dv du. And then so the limits of integration will be for v bottom is certainly 0, and v top will be described by this line. And we solve for v, so the v top will be 1 minus u, and u will be between 0 and 1. So that's how you would do the change of variables for this double integral.